You're inside a simulation of a simulation inside another giant simulation.
Right now, you're reading this. Your eyes are moving across a screen. There's light hitting your retinas, signals firing up your optic nerve, and your brain is constructing, in real time, the experience of reading these words. But here's the thing, nobody asks. How do you actually know any of that is happening? Not in a pretentious philosophy class way, I mean, genuinely. How do you know that what you're experiencing as reality isn't just information, incredibly convincing, perfectly rendered, seamlessly responsive information, being fed to whatever it is that you actually are, because some of the smartest people on the planet think it might be? And the argument they're making isn't science fiction, it's math. And once you hear it, it doesn't fully leave you. Let's start with the person who made this uncomfortable for everyone. His name is Nick Bostrom. He's a philosopher at Oxford, and in 2003 he published a paper that sounds like the opener to a bad thriller, but is actually one of the most cited philosophy papers of the last 20 years. Bostrom's argument, and stay with me here, goes like this. At some point in the future, if civilization doesn't destroy itself first, we will almost certainly develop the ability to run incredibly detailed simulations of conscious minds. We're already doing crude versions of it right now, with video games, with AI, with neural networks that can hallucinate entire realistic faces of people who don't exist. Now imagine that technology 1,000 years from now, or 10,000. A civilization that advanced could run not just one simulation, but millions of them. Billions. Simulations inside simulations, inside simulations, inside simulation. Whole universes spinning up inside a server rack somewhere, each one full of beings who think they're real. And here's the math that makes it stick. If the number of simulated minds eventually vastly outnumbers biological ones, and it would by almost any projection, then the odds that you are one of the biological ones are basically zero. You are, statistically, almost certainly living in someone else's rendering. Bostrom's conclusion is this. Either civilizations always go extinct before they get that advanced, or they lose interest in running simulations for some reason, or we are almost certainly living in one right now. He calls it the simulation argument. One of those three things has to be true. Pick your poison. Now, I want to stop here, because I know what you're thinking. You're thinking this is the kind of thing people argue about at 2 a.m. when someone's had too much coffee and someone else just watched The Matrix. But here's what blew my mind when I actually looked into this. It's not just philosophers, it's physicists. In 2012, a team of physicists at the University of Bonn were studying something called lattice quantum chromodynamics. It's a way of simulating how quarks and gluons, the stuff inside protons and neutrons, behave. They run these simulations on a grid, a lattice. And they noticed something. Their simulations had constraints. There was a built-in maximum energy that particles in the simulation could reach, determined by the size of the lattice spacing. Beyond that maximum, nothing could exist. The simulation had a hard ceiling. Then one of them, Silas Bean, asked a question that should have been uncomfortable to ask. What if we looked at our own universe for similar constraints? Turns out, we already knew about one. It's called the GZK limit. Cosmic rays that travel long distances through the universe have a hard energy ceiling. They cannot exceed a certain limit. No one had a fully satisfying explanation for why. Bean's paper suggested one possible explanation. We might be living on a lattice. The universe might have a pixel size, a resolution limit, and cosmic rays are hitting the edge of it. Does that prove we're simulated? No, absolutely not. But it means the question isn't crazy anymore. It means physicists are now asking it with straight faces. Here's where it gets weirder, and I promise I'm not just spiraling into a rabbit hole for the sake of it. Quantum mechanics is one of the most successful, most tested theories in the history of science. It predicts the behavior of particles with absurd precision, and at its core is something called the measurement problem, which has tortured physicists for 100 years. When you're not looking at a quantum particle, when it's not being measured, it doesn't have a definite position. It exists in a superposition, a blur of probabilities. The moment you observe it, it snaps into a single reality. It picks a lane. That behavior, reality only being fully resolved when something interacts with it, is uncannily similar to how video games work. A game doesn't render what you're not looking at. It calculates the minimum needed. It loads the room you're in. The moment you turn the camera, it renders that direction. There's no point computing what nobody's observing. And quantum mechanics says our universe doesn't. Things don't have definite states until observed. Energy doesn't transition smoothly. It jumps in discrete steps, like pixels, like a system conserving computational resources. I'm not saying that proves anything. I'm saying that if you were designing a simulation and you wanted to be efficient about it, you'd probably build it something like this. Now let me tell you about Elon Musk, because even if you hate tech billionaires, his version of this argument is worth hearing. In 2016, at a public conference, he was asked about the simulation hypothesis. And he said, these are close to his exact words, the odds that we're in base reality is 1 in billions. He pointed out that 40 years ago, Pong was 2 rectangles and a dot. Now we have photorealistic games with millions of players simultaneously. The trajectory of that improvement, extrapolated forward even a few centuries, leads to simulations indistinguishable from reality. His conclusion? The probability that this, right now you reading this, is the one true base reality is so small it might as well be 0. Other names have shown up in this conversation. Neil deGrasse Tyson gave it better than 50-50 odds. Physicist Max Tegmark has written extensively about the mathematical structure of the universe, suggesting it is, in some deep sense, fundamentally computational. These aren't fringe thinkers. This is the mainstream now quietly freaking out about the same thing. But here's the part that nobody talks about, because everyone gets so wrapped up in whether it's true that they skip the question that actually matters. If we are in a simulation, what would change? And the honest answer is almost nothing, and everything. Almost nothing, because the walls are still walls, pain still hurts, the people you love still matter. If the simulation is perfect, if there's no way out, no loading screen, no glitch that breaks the illusion, then it functions identically to reality. The food tastes the same. Loss feels the same. Every single thing you've ever experienced is still real in the only sense that counts. You experienced it. But here's where it gets philosophically beautiful, and this is the part that actually changes how I think about it. If this is a simulation, then whoever or whatever is running it made some choices. They decided gravity would work the way it does. They decided the speed of light would be the universal speed limit. They decided consciousness would exist, and that it would include things like grief and wonder and the specific feeling of being cold and then suddenly warm. Those are design decisions, and whoever made them made interesting ones, because they didn't have to include beauty. They didn't have to make sunsets look like that. They didn't have to make music trigger something physical in your chest, or wire your brain so that kindness to strangers feels better than cruelty. A bare simulation, the minimum viable universe needed to generate conscious observers, would not need any of that. And yet, there's one more thing, and it's the one that keeps coming back to me. In 2022, physicist Melvin Vopson published a paper in AIP Advances, proposing what he calls the second law of information dynamics. He's been studying whether information, actual digital information, like bits in a computer, has physical reality, whether it has mass, whether it can be detected. His experiments are still ongoing, but his hypothesis is that matter and information are not separate things, that the universe isn't described by mathematics. It is mathematics. It's code, running on something we don't have a name for yet. If that's true, then the question isn't, are we in a simulation? The question is, what's the difference between a simulation and reality, if they're made of the same thing? Tonight, when you close this and go back to your life, you're going to look at something ordinary. Your coffee, your hands, the way light comes through a window, and for just a second maybe, it's going to feel different. Not fake, not less real, just strange in a specific electric way, like you're seeing it clearly for the first time. That's what happens when you sit with this long enough. Not paranoia, not nihilism, something closer to the opposite. If whoever built this went to the trouble of including that feeling, the one you're having right now, then maybe the point was never to figure out if it's real. Maybe the point was just to pay attention.